Hi, welcome to Big Data Analytics course. In this, we will see Hadoop ecosystem. As part of Hadoop ecosystem, here various components of Hadoop ecosystem are introduced. Finally, we will see the important points to remember. Hadoop ecosystem is a platform or a suite which provides various services to solve the big data problems, which includes Apache projects and various commercial tools and solutions also. There are majorly four elements of Hadoop that we already covered in previous videos, that is HDFS, MapReduce, and these three we will cover. In addition to these three, the another important element is Hadoop Common. Most of the tools or solutions are used to supplement or support these major elements. All these tools work collectively to provide services such as absorption, analysis, storage, and maintenance of data, etc. The following are some of the important components collected from various sources which forms Hadoop ecosystem. See, some of the important components are HDFS, we already seen, Hadoop distributed file system, then add yet another resource negotiator, then MapReduce, programming based data processing, then Spark, in-memory data processing, then Pick and Hive, data processing services using query like SQLite, then HBase, which is a NoSQL database, then Mahout, Spark, ML, machine learning algorithm libraries, Apache Drill, SQL on Hadoop, then Solar, Lucene, searching and indexing related, then Zookeeper, managing clusters, then UG, job scheduling, then Flume and Scoop, data ingesting services, then Ambari, provision, monitor, and maintain cluster. Apart from these components, there are many other components too that are part of the Hadoop ecosystem. All these toolkits or components revolve around one term, that is data. So that is the beauty of Hadoop, that it revolves around data and hence making its synthesis easier. Let us see the following diagram which shows various components of Hadoop, which forms Hadoop ecosystem. So as we already know, the major components, HDFS, then MapReduce, we are having majorly, then ARN. Then later we have seen common. So here we are having storage manager, resource manager. Then let us see the components, Spark, then Kafka, then Storm, then Spark machine learning library, Mahout, then Apache Drill, then Solar Lucene, then UG, then Apache Ambari, Zookeeper, HBase, Peak, then Mahout, Hive and Drill, MapReduce. Here, whatever we listed the components previously, all are placed in this environment. Now, this forms an Hadoop ecosystem. Here, bottom we are having Flume with unstructured or semi-structured data, then Scoop, so which takes structured data. Yeah, this is the one pictorial representation of Hadoop ecosystem with some of the components. Let us see some of the components. We'll describe a little bit here. First, Apache Pig. It has two parts, that is Pig Latin, the language, and the Pig runtime for the execution environment. You can better understand it as Java and Java Virtual Machine. It also supports Pig Latin language, which has SQL-like command structure. Here, for example, 10 line of Pig Latin is equivalent to approximately 200 lines of map-reduced Java code. That's why it is very optimized. The compiler internally converts a Pig Latin to map-reduce. It produces a sequential set of mapped into jobs, and that is an abstraction which works like black box testing. Pig was initially developed by Yahoo. It gives us a platform for building data flow for ETL operations, that is extract, transform, and load, and also processing and analyzing huge data sets. Then how Pig works. In Pig, first the load command loads the data. Then we perform various functions on it like grouping, filtering, joining, sorting, etc. Finally, either we can dump the data on the screen or we can store the result back in HDFS file system. Then Apache Hive. Facebook created Hive for people who are fluent with SQL. Thus, Hive makes them feel at home while working in a Hadoop ecosystem. Basically, Hive is a data warehousing component which performs reading, writing, and managing large data sets in a distributed environment by using SQL-like interface. Therefore, Hive plus SQL combination is called as HQL, Hive Query Language. The query language of Hive is called as Hive Query Language, which is very similar like SQL. It has two basic components, that is Hive command line and JDBC or ODBC drive. Hive command line interface is used to execute Hive query language commands like SQL, whereas Java database connectivity JDBC and object database connectivity ODBC, which are used to establish connection from data storage. Hive is highly scalable as it can serve both the purposes, that is large dataset processing by using batch query processing and real-time processing by using interactive query processing. That's why Hive is highly scalable. Also supports all primitive data types of SQL. We can use predefined functions also or write tailor-made user-defined functions so to accomplish our specific needs. Then Apache Mahout, which provides an environment for creating machine learning applications which are scalable. What is machine learning? Machine learning algorithms allows us to build self-learning machines that evolve by itself without being explicitly programmed. Learning from the experience is the concept of machine learning. Based on user behavior, data patterns, and past experiences, it makes important future decisions. So we can call it as a descendant of artificial intelligence. Then what Mahout does? It performs collaborative filtering, clustering, and classification. Some people also consider frequent item set missing as Mahout's function. Let us see all this in detail. Collaborative filtering. So here Mahout mines user behaviors, their patterns and their characteristics, and based on that it predicts and make recommendations to the users. The typical use case is e-commerce website. Then the next one is clustering. It organizes a similar group of data together, like articles can contain blogs, news, research papers, etc. Grouping the similar items is clustering. The next one is classification. It means classifying and categorizing data into various sub-departments, like articles can be categorized into blogs, news, essay, research papers, and other categories. Then the next one is frequent item set missing. Here Mahout checks which objects are likely to be appearing together and makes citations if they are missing. For example, cell phone and cover are brought together in general. So if we search for a cell phone, it will also recommend us the covered cases in Amazon or Flipkart. We will see this type of scenarios. Finally, Mahout provides a command line to invoke various algorithms. It also has a predefined set of libraries which already contains different inbuilt algorithms for different use cases. That is about Apache Mahot. Then coming to Apache Spark is a framework for real-time data analytics in a distributed computing environment. The Spark is written in Scala and was originally developed at the University of California, Berkeley. It also executes in-memory computations to increase speed of data processing over MapReduce. It is 100x faster than Hadoop for large-scale data processing by exploiting in-memory computations and other optimizations. Finally, it requires high processing power comparing to MapReduce. Yeah, this is one of the sample architecture taken from Edureka tutorial. Let us see here we have Spark SQL plus and data frames, then streaming, then machine learning library, then GraphX for graph computation. The Spark Core API uses the following languages. Initially, the original one is Java, then Scala, then Python, then SQL, then R. Spark comes packed with high-level libraries, which includes the support for R, SQL, Python, Scala, Java, etc. These standard libraries increase the seamless integrations in complex workflow. Over this, it also allows various sets of services to integrate with it, like machine learning library, graphics, SQL plus data frames, streaming services, etc., which increases its capabilities. That is about Apache Spark. Also, Apache Spark best fits for real-time processing, whereas Hadoop was designed to store unstructured data and execute batch processing over it. When we combine Apache Spark's ability, that is high processing speed, advanced analytics, and multiple integration support with Hadoop's low-cost operation on commodity hardware, it gives the best results. Spark and Hadoop are used together by many companies for processing and analyzing their big data stored in Hadoop distributed file system. The next component is Apache HBase. Is an open source, non-relational distributed database. In other words, it is a NoSQL database which supports all types of data, and that is why it is capable of handling anything and everything inside a Hadoop ecosystem. It is modeled after Google's Big Table, which is a distributed storage system designed to cope up with large data sets. The HBase was designed to run on top of HDFS and provides big table-like capabilities like Apache Hive SQL-like, whereas HBase big table-like. It gives us a fault-tolerant way of storing sparse data, which is a common in most big data use cases. The HBase is also written in Java, whereas HBase applications can be written in REST language, that is representational state transfer. Then Avro, that is Apache Avro, is a data serialization system and Thrift APIs. So Apache Thrift software framework for scalable cross-language services development. Then Apache Drill is the next Hadoop ecosystem component. As the name suggests, Apache Drill is used to drill into any kind of data. It is also an open source application which works with a distributed environment to analyze large data sets. It is a replica of Google Dremel. It supports different kinds of NoSQL databases and file systems, which is a powerful feature of Drill. For example, Azure Blob Storage, Google Cloud Storage, HBase, MongoDB, Map or DB HDFS, Map or FS, Amazon S3, Swift, NAS, and local files. These are some of the examples. Also, basically, the main aim behind Apache Drill is to provide scalability so that we can process petabytes and exabytes of data efficiently, even we can say in minutes. The main power of Apache Drill lies in combining a variety of data stores just by using a single query. Apache Drill basically follows the ANSI SQL standard. It has a powerful scalability factor in supporting millions of users and serve their query requests over large scale data. Then the next component is Apache Zookeeper is the coordinator of any Hadoop job, which includes a combination of various services in Hadoop ecosystem. Apache Zookeeper coordinates with various services in a distributed environment. Before Zookeeper, it was very difficult and time consuming to coordinate between different services in Hadoop ecosystem. The services earlier had many problems with interactions like common configuration while synchronizing data. Even if the services are configured, changes in the configurations of the services make it complex and difficult to handle. The grouping and naming was also a time consuming factor. Due to these problems, Zookeeper was introduced. It saves a lot of time by performing synchronization, configuration maintenance, grouping, and naming. Although it is a simple service, it can be used to build powerful solutions. Finally, big names like Rackspace, Yahoo, eBay use this service in many of their use cases, and therefore we can have an idea about the importance of Zookeeper. Then Apache UG. Consider Apache UG as a clock and alarm service inside Hadoop ecosystem. For Apache jobs, UG has been just like a scheduler. It schedules Hadoop jobs and binds them together as one logical one. There are two kinds of UG jobs, that is UG workflow and UG coordinator. Then UG workflow, mainly the responsibilities are, these are a sequential set of actions to be executed. We can assume it as a relay race, where each athlete waits for the last one to complete his spot. Then UG coordinator, these are the UG jobs which are triggered when the data is made available to you. So think of this as the response stimuli system in our body. In the same manner as we respond to an external stimulus, an UG coordinator responds to the availability of data and it rests otherwise. Then Apache Flow. This is ingesting, that is, absorb information. Ingesting data is an important part of our Hadoop ecosystem. The Flume is a service which helps in ingesting unstructured and semi-structured data into HDFS. It gives us a solution which is reliable and distributed and helps us in collecting, aggregating, and moving large amount of data sets. It also helps us to ingest online streaming data from various sources like network traffic, social media, email messages, log files, etc. in HDFS. Yeah, this is the sample architecture taken from Hedureka tutorial of Apache Flume. Here we are having web server. Here right side we are having HDFS. Between here we are having channel which consisting of source and sink. So here agent is there to communicate the task. There is a simple architecture of Apache Flow. So there is a Flow agent which ingests the streaming data from various data sources to HDFS. From the previous diagram, we can easily understand that the web server indicates the data source. Twitter is among one of the famous sources for streaming data. The Flume agent consisting of three components, source, sink, and channel. Source, which accepts the data from the incoming stream lane and stores the data in the channel, where a channel acts as the local storage or the primary storage. Here, a channel is a temporary storage between the source of the data and present data in the HDFS. Then sink is the last component, which collects the data from the channel and commits or writes the data in the HDFS permanently. Then the next component is Apache Scoop. The major difference between Flume and Scoop is that Flume only ingests unstructured data or semi-structured data into HDFS, whereas Scoop can import as well as export structured data from RDBMS or enterprise data warehouses to HDFS or vice versa. That is the major difference between Flume and Scoop. Yeah, this is the sample architecture of Apache Scoop again taken from Edureka tutorial. Here, a Scoop user provides command, then this is the Hadoop environment, which consisting of map task, then HDFS, HBase, Hive. Then here, the data from enterprise data warehouse, document based system, relational database, various databases here. So when we submit scoop command, our main task gets divided into subtasks, which is handled by individual map task internally. Map task is the subtask which imports part of data to the Hadoop ecosystem. Collectively, all map tasks imports the whole data. Then export also works in a similar manner. So here we have folder. So exporting data. So first from Hadoop cluster, we are having HDFS storage. Then each storage here map task is assigned. This will call it as scoop job by using mapper. So first here every storage through scoop job interacts with the folder to get the data to apply the mapper. So here you can see, so first we have to gather metadata, then submit map only job. So here this is the scoop export mechanism. When we submit our job, it is mapped into map task, which brings the chunk, means block of data from HDFS. These chunks are exported to a structured data destination. Combining all these exported chunks of data, we receive the whole data at the destination, which is in most of the cases is an RDBMS like MySQL, Oracle, or SQL Server. Then Apache Solar and Lucene. Apache Solar and Apache Lucene are the two services which are used for searching and indexing in Hadoop ecosystem. Apache Lucene is based on Java, which also helps in spell checking. Apache Lucene is the engine, whereas Apache Solar is the core built around it. Solar is a complete application built around Lucene. It uses the Lucene Java search library as a core for search and full indexing. Then Apache Ambari is an Apache Software Foundation project which aims at making Hadoop ecosystem more manageable, which includes software for provisioning, managing, and monitoring Apache Hadoop clusters. The Ambari provides Hadoop cluster provisioning, Hadoop cluster management, and Hadoop cluster monitoring. Let us see all this. Hadoop cluster provisioning, which gives us step-by-step process for installing Hadoop services across a number of hosts. It also handles configuration of Hadoop services over a cluster. Then Hadoop Cluster Management provides a central management service for starting, stopping, and reconfiguring Hadoop services across the cluster. Whereas a Hadoop Cluster Monitoring component for monitoring health and status. Here, Ambari provides us a dashboard. The Ambari Alert Framework is an alerting service which notifies the user whenever the attention is needed. For example, if a node goes down or low disk space on a node, etc. Finally, attention on the following three important points. Hadoop ecosystem finally brought its success to the whole developer community. Many big companies like Facebook, Google, Yahoo, and University of California, Berkeley, etc., have contributed their part to increase Hadoop's capabilities. Inside a Hadoop ecosystem, knowledge about one or two tools, Hadoop components, would not help in building a solution. That's why we need to learn a set of Hadoop components which work together to build a solution. Then the last note is attention based on the use cases. We can choose a set of services from Hadoop ecosystem and create a tailored solution for an organization. These are the three important points you have to remember finally with the Hadoop ecosystem. Inside a Hadoop ecosystem, then based on the use cases. In upcoming lectures, we will see other interesting topics related to Hadoop. Till then, stay tuned. All of you very happy learning.